So class 43 is an application of centrifuges. So let's get going. So there's a couple of videos here for you to watch. But I'm going to go all the way down here. I'm really going to start going towards the math stuff because that's where some people are struggling. So we have a centrifuge with a radius of 18 meters. So let's write that down. R is 18 meters. And it spun around once every 5.5 seconds. So we need to find the tangential velocity, the centrifugal, or really centripetal acceleration, and how many g's this is. Okay, so first things first is to find the velocity. So this thing spins around in a circle once every 5.5 seconds. So if we use this equation to find tangential velocity, v equals d over t, the distance, what's the distance to go around a circle? It's 2 pi r. It's the circumference, 2 pi r over t. So the velocity is, let's see, 2 pi, 18 meters over 5.5 seconds. That ends up being 20.6 meters per second. To get the centripetal acceleration, AC equals v squared over r. 20.6 squared over r is 18. 23.5 meters per second squared. Now to get the number of g's, 1 g is 9.8 meters per second squared. So 23.5 meters per second squared over 9.8 meters per second squared gives us 2.4 g's. How the number of g's the astronauts experience change if the centrifuge were spinning at a different speed? Well, if it were spinning faster, so if v were greater, the centripetal acceleration would go up. Therefore, the number of g's would go up. Slower, the centripetal acceleration would go down. Therefore, g's would go down. What if the radius were different? Well, if the radius were smaller, AC would go up, right? If r is smaller, AC would go up. It's an inverse relationship. Therefore, the number of g's would go up. If r were bigger, then AC would go down. Therefore, the number of g's would go down. All right, so here's another video. Every class may have had a different radius here, but we chose for this class 5 meters. So that would be our radius in this case of the hub. All right, now the centripetal acceleration to be the same as the acceleration due to gravity would be 9.8 meters per second squared. So we have to find the tangential velocity first, then the period of rotation. So to get the tangential velocity, AC equals v squared over r. AC is 9.8 meters per second squared. V is our unknown, and r is 5 meters. Cross multiply and take the square root. V should end up being 7 meters per second. Now to get the period of rotation, v equals d over t, but more specifically, since it's going in a circle, v equals 2 pi r over t. So I'm going to bring it over here. V is 7 equals 2 pi, r is 5 over t. Cross multiply, t ends up being 4.5 seconds. That's how long it takes to spin around once. Right, and we didn't have to do the extension question there. All right, so that's class number 43.